We now turn our attention to speech synthesis. We shall focus on the literature, and we shall also have a detailed treatment of the techniques that are involved in speech synthesis. So in trying to synthesize speech, the main task is that we want to generate naturally sounding speech, usually from text, okay? Although there are two main approaches. The commonest is speech, text to speech, but then we also have concept to speech, okay? So the main difficulties are what to say and how to say it, okay? We are going to see this in the next slides. Concept to speech is simple, okay? The content of the message that is going to be synthesized is determined from an internal representation and not by reading out text, okay? For example, you can program your system to say if the result is 0, say no. If the result is 1, say yes, okay? This is what we mean by concept to speech. So in text-to-speech synthesis, you're already quite familiar with it. We simply have text and we need it spoken out. A very common feature is the Adobe read out loud feature. If you have a document with text in Adobe, you can read it out loud. That is an example of text-to-speech. Now, it's actually not a very straightforward process because text to phoneme conversion is complicated. You remember the definition of a phoneme. A phoneme is the smallest linguistic unit that can bring about a change in meaning, okay? For example, take a look at those two statements before. The first one is read that book. Sorry, that question mark is not supposed to be there. It's supposed to be a full stop, okay? So I would say read that book. And the second statement is I read it 2 days ago. So in this particular case, the text is the same, but it can be pronounced in two different ways, okay? So it's not just a matter of choosing the appropriate phonemes, but you have to look at a number of things. In this particular example, these are called allophones, okay? A set of multiple possible spoken sounds that are used to pronounce a single phoneme. So in this case, if the phoneme can be RE and it can be read as RE or it can be read as RE. Then we have co-articulation, okay? Every speech sound is affected by a sound in its environment. So that also has to be put into consideration. Then we have the prosodic features, okay? The pitch, the loudness, the length, okay? For example, one word in Runyankore can be pronounced, well, the standard way, but in Rutoro, there may be what we call more prosody. I am going to tell you exactly what prosody is. This is a simple architecture of a text-to-speech system, TTS, okay? We have the text-to-phoneme module in which we have the text input. The text input is normalized. Then we get the text in what we call orthographic form. And then we have the graphemes converted to the phonemes, okay? In normalization, one possible input is what we call the abbreviation lexicon. For example, if we are reading, if the name is Mr. Maximus Biamkama, that is Mr. Maximus Biamkama, it should be read Mr. It shouldn't be read as Mr. So such definitions of the abbreviations MR, DR, MS, MRS for Mrs. They are all contained in the abbreviation lexicon. It's a database of abbreviations, okay? So after that, you basically get the text in orthographic form. Orthographic form is the normal way of writing, okay? In other words, DR is equal to doctor. So doctor is the orthographic form of DR, okay? Then in orthographic form, that means now we have graphemes, okay? I haven't yet explained what a grapheme is, but a grapheme is the phoneme. Only that phoneme is to spoken language as grapheme is to written language. So a grapheme is the smallest written unit that brings about a change in meaning, okay? So the grammar rules of the language, the orthographic rules, how a statement should be written, and any exceptions are all inputs as we're trying to convert from a grapheme into a phoneme, okay? And then we get out the string of phonemes. The string of phonemes is now an input into the phoneme to speech module. we model what we call the prosody. Okay, is it a Spanish person speaking? Is it a Brazilian speaking? Is it an American? Is it an Englishman? All these will pronounce English in different ways. So the harmony with which they speak, the loudness, the pitch, all this is what we call prosody. So the phoneme string now comes with the prosodic annotation, and then we perform the acoustic synthesis. There are various methods of acoustic synthesis which we're going to see, and then eventually we have the synthetic speech output. So text normalization, I've already explained it, but just to do it again, any text that has special pronunciation should be stored in the abbreviation lexicon. Well, in a lexicon generally, abbreviations, acronyms, special symbols like the percent sign, particular conventions like 12 degrees Celsius, numbers, okay? Should we say 1995 or should we say 1995, okay? Acronyms, we can have UN for United Nations, then we have UNESCO. So what should we say? Should we say UN? We can use UN, the UN ambassador. But then sometimes we may need to tell people exactly what UNESCO is. So it depends on the syntax that you want. Do you want UNESCO to be read out loud, or do you want it to be also read as an abbreviation? Okay. So things like this, all these are supposed to be stored in lexicon, which should eventually be normalized such that the text can be represented in what we call the orthographic form. Okay, RD means road, ST means street. Okay, mid-X I think is for Middlesex. Okay, which is a city in the United Kingdom. Now, a grapheme is the smallest semantically distinguishing unit in a written language, and it is analogous to a phoneme in a spoken language. We have already seen this. Okay, a grapheme will usually actually not carry meaning by itself, and it may not even correspond to a single phoneme. Graphemes include alphabetic letters, typographic ligatures, Chinese characters. A whole Chinese character can be considered as a grapheme, numerical digits, punctuation marks, etc., etc. Okay, a comma will bring about a change in meaning. A semicolon will bring about a change in meaning. Changing a symbol alphabetic character will bring about a change in meaning. Okay, numerical digits, each digit has its own meaning. So you see that a grapheme is actually a smaller, in a sense, it's a smaller unit than a phoneme. Okay, we may need more than one grapheme to correspond to one phoneme. The question for this slide is, what is a typographic ligature? That is an assignment. Now, there are many phonemes that may have multiple pronunciations. Okay, we have already seen the concept of an allophone. I spoke about it. When we looked at the example of the word read. It can be pronounced read, it can be pronounced read. Okay. Now, this is a common problem in text-to-speech systems. We have the same phonemes, but then they have multiple pronunciations. Okay, and this is called allophonic variation. Okay, variation in the allophones. It manifests itself in three types. Okay. The first type is what we call free variation. Free variation means that the two forms of a phoneme can be used in the same environment without any restriction. For example, the word economics, typically, many people call it economics, but other people may call it economics, okay, depending on where they come from, the country, how they learned the English. Even within the same country like Uganda, it depends which school you went to. Some people call it economics, other people call it economics. Then we have what we call conditioned variation. Conditioned variation is generally a rule that governs when we use one form of a phoneme and when we use another. For example, it could be a verb, it could be a noun. Take a look at the word import. Okay, if it's a noun, we say import. This is an import. Okay, these are imports. If it's a verb, we say import. Okay, we don't say he imports sewing machines. No, we say he imports sewing machines. So one is a verb, one is a noun, and they're pronounced differently. That is conditioned variation. And the final way in which allophonic variation manifests itself is in genuine homographs. A homograph is a word that shares the same written form as another word, but it has a totally different meaning. Okay, for example, bear, we have bear the animal, then we have bear to bear maybe burdens, to bear or to bear a child. Okay, compound, we have compound, the compound in front of your house. We have compound, meaning something is composed of very many different things. It's a compound. We have the verb to compound things, etc, etc. All these are, it's the same word, one written form, but then the meaning is different. Grapheme to phoneme conversion is much easier in some languages, such as Spanish and Czech and Korean. Why? Because in these languages, the way something is written is the way it is pronounced to a larger extent. Okay, in Korean, for example, you find one whole symbol is pronounced in one way, and that's it. However, it's much harder for others. In English, French is much more complicated than English. Okay, because the way something is written in a particular way and it is pronounced in a totally different manner. Okay, I guess German also falls in that category. Now, it's even harder if the writing system is only partially alphabetic. Okay, Arabic and Urdu use totally different writing systems, so grapheme to phoneme conversion is extremely difficult. Some languages are not alphabetic at all, such as Chinese and Japanese. What does this mean? It means that there are no alphabets. For example, in English, you have an alphabet of 26 letters, and you can construct various words using those 26 letters. In Chinese, symbols represent things. There is no such thing as a Chinese alphabet. For example, if you want to say the moon, you write the symbol for a moon, and that is the symbol for a moon. It doesn't mean anything else. If you want to say a sun, you write the symbol for the sun. Okay? If you want to speak about going, the verb, you write the symbol for go. So there's no alphabet in a strict sense. That is why there are thousands of various Chinese symbols, and over the lifetime of a Chinese individual, they have to memorize each of these symbols and apply them to their writing style. Okay? Japanese is just slightly easier than Chinese, but the same concept applies. Okay? There is no alphabet. So, in fact, Japanese, you can now write Japanese using the Arabic alphabet, not the Arabic alphabet, the Roman alphabet. People are trying to start writing Japanese using the Roman alphabet, such that you no longer have to go through all the complex writing styles. Okay, but this is what we mean by a language not being alphabetic. There is no set of letters that you use to construct words. Table, chair, everything has its own symbol. Yeah. Syntactic analysis is usually used to distinguish between homographs. Okay, a syntax is the way something is, let's say, written. You've looked at syntax errors in computer programming. Okay, so what happens is that whenever we have a statement in which we have a possible homograph, we have to look, the text-to-speech system has to look at the context, okay, and apply some syntax rules for it to be able to pronounce it correctly. Okay, for example, statement number 1 is, he makes a record of everything they record. These are two similar words, different pronunciations. Okay, I read a lot. What have you read recently? Okay, so these are homographs. These are homographs, and we need to pronounce them differently. Syntactic analysis is also essential to determine appropriate prosodic features. Okay, Well, this is exactly what I've been doing. In the first statement, for example, record and record. Record has a prosody applied to it. Okay, record is a bit flat. So what is prosody? Prosody is the rhythm, the stress, and the intonation of speech. That includes the length, the loudness, and the pitch. For example, Lusoga has more prosody than Luganda. Okay, the way in Luganda someone can just say omusajja, in Lusoga they would say omusada. Okay, there's some rhythm applied to it. In Runyankore Ruchiga I can say ninjenda, I'm going. The Banyoro Batoro would say ningenda. There is a particular intonation that is applied to it. So there is more prosody. And this is a common problem because sometimes something is written the same way, but you have to model the prosody depending on the environment in which this speech is going to be spoken. Okay? So we need to avoid monotonous robot-like voice. This is common to very many text-to-speech systems. Okay? Siri, for example, speaks with a very nice female American accent. That is prosody right there. Okay, instead of speaking like the old systems that were speaking like robots. Okay, on YouTube I listened to a video in which Stephen Hawking is trying to, he types into a computer and it speaks, and the way it speaks is a pure robot. Okay, so prosody tackles the intonation of speech and the rhythm. Rhythm has to do with the pace and the length of speech. Sometimes there's need to pause at appropriate places. Okay, that is rhythm. Now, we now look at acoustic synthesis. There are 4 main techniques. Once you have gotten the phoneme string out and you have gotten the appropriate prosody modeling, it is now time to synthesize speech. And there are 4 main techniques. We're going to look at each of them briefly. The first technique is articulatory synthesis. This uses the source filter model. We basically simulate the physical processes of the human vocal tract. Okay, you write code, and in the code you have different filters. Each filter tries to mimic the vocal tract shape, the articulatory positions. They try to mimic the lips. They try to mimic the tongue. It was first invented by this fellow, von Kempelen. He used reeds and tubes to construct mechanically speaking machines. Okay, so for him he used hardware, mechanical hardware, but it can be implemented in terms of software. And most text-to-speech systems use articulatory synthesis. Then we have formant synthesis. This is an assignment for you. Okay, I need you to do some further reading about formant synthesis as an acoustic synthesis technique. Okay, a question can come, for example, saying, write brief notes about formant synthesis. 5 marks. Okay, that's an assignment. Do it. Then we have concatenative synthesis. This is really straightforward. We have a database of previously recorded human speech covering all the possible segments that need to be synthesized, and we write code to just combine them. This is, I think, part of your lab 2 in the assessment that I gave you. Okay, that is concatenative synthesis. We concatenate segments of pre-recorded natural human speech. So of course this means that you need to have a big database, a big file storage system in which there are several pre-recorded phonemes, syllables, words, phrases, or any combination, or even full words. Okay, full, like the common words the, most of those common words, you just record them alone. Then we have unit selection synthesis. This is the same thing roughly as concatenative synthesis, only that here we have a bigger variety of units. We can record, for example, several phonemes under different prosodic conditions, okay? And when it is time to synthesize the speech, we look through the database and we select the appropriate candidate for a particular situation, okay? Of course, this means that looking through the database, running those queries is going to be much more complicated because you have to choose between a bigger variety of pre-recorded speech. Okay, those are the 4 techniques, and I believe that is the end of the lecture. Thank you.